Hello, everybody. Welcome back. We've got another lesson today. Before we start, I've got a bit of a brain teaser for you. See if you understand what I mean. Did you know that 10 plus 10 and 11 plus 11 are the same number? Have a think about it. All right, so today we are going to continue on with our work on ratios. And so if I can get this up on the screen, we'll have it right here. Boom, three, two, one, and we're good. So today we'll be doing the topic of equivalent ratios. Now, equivalent just means equal to. Now, remember how last time we said that fractions and ratios are kind of like sisters, not twins. So they're similar. So just like fractions, ratios can also be simplified and also unsimplified. Also, by the way, I'm using my proper mic. Let me know in the comments if that sounds better. So just like fractions, ratios can be simplified and unsimplified. So for example, a very common one is 1 over 2 or a half. It's the same thing as 2 out of 4 or 3 out of 6 or 4 out of 8 or 5 out of 10. They're all the same thing as a half, right? So in the same way, we can write a ratio 1 to 2 is exactly the same thing as 2 to 4, which is the same as 3 to 6, 4 to 8, 5 to 10. They are exactly the same. Now, of course, your examples are not going to be that easy. You might have an example that might look a little bit like this. And let me show you how we would go about solving these. So if we want to complete these equivalent ratios, part of what we're going to do is we're going to have to find, okay, how did we get from that number to the other number? Let me show you what I mean. So first here, I'm looking at my first two numbers and they're supposed to relate together. Now, how did I get from 1 to 4? Oh, well, I obviously would have had to multiply by 4. Now, a very common mistake here is people would use add and subtract. Do not use add and subtract here. Only use multiply or divide. So if I go from 1 to 4, that's times by 4. And so take a guess. What do you think I'm going to do from that 3? I'm also going to multiply it by 4. So here I can see that 1 to 3 is also going to be the same as 4 to 3 times 4, which is 12. So that there would be our equivalent fraction. Right, so if you want, you can write 12 in the box. It's up to you. Okay. Now, same thing here. Now, this is a little bit different. It goes the other way. So here I've got the second number, and I don't know the first. So I'm going to deal with the second number here, and I'm going to find out, okay, how in the world did I get from there to there? What did I have to do to get from 56 to 8? Now, hopefully you're comfortable with your times tables. I know for me, that's going to be, okay, I'm dividing by 7 here because, 56 divided by 7 or 8 times 7, that's going to give me 56. So again, if I divide by 7 that way, then what am I going to do for this 21 here? I'm going to do the same thing, and I'm also going to divide by 7. So what's 21 divided by 7? If you said 3, you are correct. And so we can write here that 21 to 56 is the exact same thing as 3 to 8. Hopefully that makes a little bit of sense, right? Whatever we do to the first number or the second number, we have to do to both the terms. It's the same. Okay, very similar to how we deal with fractions now. Now let's move on. So equivalent fractions, I guess why are they useful? Is they're useful when we want to scale things up. If you remember from last time, my coffee ratio was 1 to 15, right? But what I did was I don't want 1 gram of coffee and then 15 grams of water. That's going to give me 15 grams of coffee. What am I going to do with that, right? What I want is I want a decent amount of coffee. So I changed it from 1 to 15. I changed it from 30 to 300. Wait, no, that doesn't make sense. 20 to 300. That's better. So we can scale things up. If you're making a cake and you want to make a bigger batch, that's when we would use equivalent fractions. But how we want to express our ratios is in their simplest form, right? We don't like things to be difficult. We don't like things to be complex. If we can simplify it, that's what we're going to do. So we're going to learn right now how to simplify a ratio. Now, just remember, I want you to remember this about ratios. A ratio needs to be two quantities measured in the same unit. Okay, now that's going to be important when we answer some of these next questions, but remember, a ratio compares two quantities of the same, exactly the same unit. Okay, so let's take a look at this example here. We've got express the following ratios in simplest form. Okay, now that there is one of the key words, simplest. Simplest means, it simply means that it's like it can't be simplified anymore. Right? Can't be any more simple. Right? So that means simplest. Now let's take a look at 42 to 48. Now for this one here, what I want to do is I want to find what we call our highest common multiple. Oh, sorry, factor. We're trying to find our highest common factor. That means what number is going to divide nicely into 42 and into 48 without any remainders. Now, I know 1 will go into both, but that's not my highest. 2, that's looking a bit better. 3 is actually going to work as well, but it's not going to be 3. 4 won't work in this case. 5 won't work. 6 will, and 6 is going to be my highest common factor here. If you guys need to look over that, please look over it. But highest common factor, I'm going to write HCF is going to equal to 6, right? Highest common factor. Now, once I know what that is, so 42 to 48, all I need to do is divide my highest common factor to both those numbers. So I'm going to write it like this. I'm going to divide this number by 6, and I'm going to divide this number by 6. Okay, so 42 divided by 6, that gives me 7. And I'll get 48 divided by 6, that's going to give me 8. Now, if I take a look at this, 7 to 8, I can't get any simpler than that because there's no other highest common factor between the two, right? I can't simplify it anymore. Now, for something like part B, right, we've got part B here. And so we've got 2 hours and 15 minutes. Okay, I want you guys to think here. Hours and minutes, are they the same? No, right? They're very, very different, right? They're different measurements. They're still measuring time, but they're in different units. So what we have to do is we have to change them both to something of the same. So for me, it's going to be easiest, I think, to change both into minutes. Okay, so we know that 15 minutes is just 15 minutes. But 2 hours, how many minutes is that? Well, there's 60 hours in a minute, so there should be 120 minutes. Right now, the beauty of ratios is I don't need to write the units, right? Because I know they're the same. Right, so now I just write it as 120 to 15. And then all I have to do now is figure out, okay, can I simplify that any further? Is there a highest common factor here? Right, I'm looking at my highest common factor, HCF. And here I'm going to see that it's 15 as well, because 15 goes into 15, but 15 actually also goes into 120. So let's see how many times. So we're going to do, well, 15 divided by 15. Remember, we divide by the highest common factor, divide by 15, divide by 15. 15 divided by 15 is 1. And 120 divided by 15, well, I'm just going to think in my head, you can put this in the calculator, but I know 15 goes into 32 times, and I know that goes into 124 times, so 2 times 4, that's going to give me 8. Now, of course, you can just do 120 divided by 15 in your calculator. I'm not going to judge you for that. All right, so 8 to 1, can I get any simpler than that? Not really. That's as simple as it gets. Okay, so we've got something from 2 hours and to 15 minutes. I can just say 8 to 1, a lot simpler. Okay, and last one, hope you guys are bearing with me. Okay, so this one here, we've got 45 centimeters to 3 meters. Again, I'm going to look at these units. Are they the same? They are not. So I'm going to change them so that they are the same. So I'm looking here, would it be easier for me to do centimeters or meters? I think this time it's going to be better for me to do centimeters, right? So that way I don't have any decimals because they make things difficult. So let's not work with any decimals. Let's keep it as centimeters to centimeters. Now 45 centimeters is 45 centimeters. How many centimeters is 3 meters? 30. I'm kidding. You guys got me. 300. Okay, so we've got 45 to 300. Okay. Now again, that means I can write it without the units because I know that they are the same. So it's 45 to 300. Take it a little bit further. All right, let's see. How many times will what's going to be our highest common factor here? Or even not, let me show you a trick of what you can do if you can't find the highest common factor. I'm just going to keep going until I find the simplest I get, very similar to simplifying a fraction. So what goes in 45 and 300? I'm going to say 5. So if I divide both sides by 5 first, divide by 5, divide by 5. Okay, now 45 divided by 5 is 9. Okay, now I'm going to do the same thing to the other side. 300 divided by 5 is now, if I'm not wrong, it's 60. Now I look at 9 to 60. Does that look as simple as it can be? Not quite. I think I can still simplify it some more. And here I can see, you know what, I can definitely divide each by 3. Okay, so I'm going to divide each side by 3, divide by 3, divide by 3. Let's see what we get. What's 9 divided by 3? It's 3. 60 divided by 3 is 20. Now, if I look at 3 and 20, can I divide that any more? Can I simplify it any further? No. So 3 to 20. So that means 45 centimeters to 3 meters is the same ratio as 3 to 20. Right? A lot simpler, a lot easier. And that's how we would do that. Okay, bit of a longer one today, but hope that was helpful. All the best with the exercises and see you guys later. Bye. Stop share. Stop recording.